Hey, this is John. I'm going to be talking about my project on the efficacy of structure for motion photogrammetry and assessing physical parameters of street trees. It's going to diverge a little bit from what we've seen in class with like PhotoScan and Fusion in that those were aerial applications. This is going to be more of a ground-based um, perspective on what you can do with this type of uh, technology and using it more on a terrestrial perspective. So here's an example of the closest thing that has been done to what I was trying to do with the project. It's just a proof of concept. Basically, they went out there and took pictures of this tree, and just to show that this is what you could do with it, and that maybe that there's some application out there. Terrestrial lidar and mobilized versions of like of terrestrial lidar also exist, but they're kind of restricted in the sense that they're kind of they're expensive to use. Whereas all this takes is the software package um, and a camera. So they're just they're just trying to find the extent to what you can do with this in terms of picking up physical parameters from a landscape. And here's another example of what it looks like when you put the mesh in and it's a finished product. As you can see, photogrammetry does have limitations. There's not a lot of vegetation or anything like that. That it's a little bit too complex for it to handle. So a lot of the application regarding this is geared towards small municipalities and things like that that could potentially use this to go out and get field measurements of their street trees for a variety of reasons. I mean, like getting carbon stocks, property risks, density surveys for irrigation, all sorts of things. Um, so so the field surveys are pretty intensive in terms of people going out there and collecting data. So this would potentially um, give them a higher hypertemporal perspective on what's out there if they're able to set this up and do better assessments of seeing like what the trees look like in uh, the areas that are under their jurisdiction in management. Might be able to aid them in performing management type tasks. So, I mean, given the limitations like shadow and overly repetitive image compositions, occlusions, things that are problematic for these photogrammetry programs like PhotoScan, is it possible to use it to get uh, physical parameters of street trees? And specifically for what we're looking at, we want to see if it can do the task of being able to get the DBH, which is diameter at breast height. It's 1.4 meters above the ground, but it's a commonly used parameter for assessing volume of trees. So here's the field site that I ended up using. You can tell here from the map on campus, it's near Southwest Rec Center, pretty close to the softball fields in that area on Museum Drive. We wanted to choose somewhere that wasn't overly complex in terms of what we were trying to pick up in the background. So we've got one layer of trees here, and then there's a second one behind that, but you can't see them because they're deciduous. So what we ended up doing was I measured at a 30-meter transect, and I took pictures facing away from the road every half meter or so. And I also went out there and took field measurements on the diameters of the trees for comparison to what we were going to get in AggieSoft. And I also put control points on all these trees so that there was at least one control point visible for each of the pictures. And then because of the way that the program's set up, you can just take field measurements. So I just took a few measurements between points out here and manually input them later on in AggieSoft in order to get our scale instead of doing everything from a georeference perspective. So after uploading the photos onto the computer and importing them into PhotoScan, this is what was produced at 30,000 points, I believe, and applied textures and mesh. So there were a few little problems. For example, you can see like right here along one of the control points, I lost a couple trees. I think it could have been because they were too close to the camera, or it could have been that this was at the edge of the range. As you can see here, this is the same point a little bit further down the road. Of where I was taking photos, and they might have been left out because of that, or some combination. So here's how the image came out looking from behind. I mean, everything's not perfect, but I mean it did a decent job of showing what like was available to the cameras and piecing it together. So I exported it as a text file and uploaded it onto Cloud Compare. And the reason for this was that Cloud Compare, I was able to pull out individual trees, and then from there I could convert them to another file, and take them to a quick terrain reader. So I converted these Cloud Compare files to an LAS and put them on Quick Terrain Reader, which has a better measuring tool for what we want to do. So here it is uploaded on Quick Terrain Reader, and so I'd go up and mark at 1.4 meters, and then from there I would try and just measure from side to side. So, and as you can see, there's you can tell pretty much the extent of where the tree would have been. There's a little bit of noise on the sides here, but based on the high density, you can pick out where the size of the tree are. So here's an image of a tree that's a little bit further away. As you can see, there's a lot more noise. It was a smaller tree, and overall, it's not very circular, very concave, and so it was a little bit harder taking measurements on these trees. And here's another perspective of that same tree. So, and for comparison, the tree on the left, that is one of the trees that we were just looking at. It's a little bit further away and smaller. And to the right is a tree that was much closer to the road. And you can see that like there's a lot less noise along the sides. It appears to have a much more concave structure, showing that like we probably got a better measure of what the diameter is for this tree when I was able to go in and use the measuring tool. So, and here's another perspective of that. Is this one right here is on the left. This is that same large oak. Then on the right, it's the smaller ash tree. So here's the overall results. As you can see, we didn't get a ton of trees that were fairly close to the road. Up here, the Quercus virginiana, Pinus eleodii, versus trees that were further away. All these were probably like 25 or 30 meters away or more. And so, but I'd like to draw your attention to like the averages in terms of the disparity between what the actual trees versus what was estimated in Quick Terrain Reader. And so the trees that were closer and were larger, there really wasn't a whole lot in their difference there. It's about, I mean, it's probably good enough for most applications, especially if you just keep using the same technology. but there were a couple limitations. One of them being that like I couldn't, the smallest unit I could get to with quick terrain reader was to the centimeter, instead of like what I recorded in the field was to the tenth of the centimeter. So that, I mean, that would have been nice to be able to get at, but that's something that I could probably address down the road, um, either by modifying those settings or using a different program. So, and on a similar note, the uh, this tree in particular, it was only a centimeter off as well, and it was one of the closer trees in terms of the ones that were uh, taken from uh, the further distance, and also it was a larger tree as well. So, I mean, between those two things, distance and size seem to be like parameters I need to like hone in on for future purposes. So what does it all mean? Um, I got a pretty decent product. I mean, it would be nicer, or nice down the road to see if I could make it a little bit easier to use and do a little more testing to make sure that that product's all right. But it's really not too bad, and that's really all we wanted to try and do at this point, was to see if like it could be done. So, so where do I go from here? So, like I mentioned, try a little bit more, and make sure that the results just aren't some kind of an outlier, and see if I can duplicate them, um, and then potentially take some of, see if like the things that were problematic, like the trees that disappeared, can be addressed, um, and see if, you know, if I can potentially get better results in terms of the trees that are further away by increasing my the number of points or decreasing the number of points, settings inside the computer, that kind of thing. And you know, I guess go and see what, to what extent these methods can be used. So this was a pretty simple environment to have tried this out. So the next step would also be taking this to more complex environments like people's yards and stuff like that, and seeing what happens when it has more problems dealing with perspective and shadow. Yeah, and potentially comparison to LiDAR would be pretty nice as well. And I mean, what I will be doing for a lot of my research, I mean, that's kind of the gold standard, in terms of having a decent product. And so if you're trying to, I mean, there's just as a lot to be done out there in terms of seeing how does this stack up to um, lidar, and trying to get different, and especially in terms of like the different physical parameters and stuff like that. And I'll be doing that as well, comparing to lots of physical parameters. And then also I'd like to see about making it a little bit easier on myself and others, and seeing about looking into programs that can automate the process a little bit more easily. Um, Either, you know, also by, I mean, in a couple different ways. One of them is the using the points to uh, that you select within PhotoScan, to meet up more easily with the trees. And then another way would be also be like being able to take out the points that I'm interested in, or the point clouds that like are at DBH, and then measuring across for diameter, um, instead of having to go through with quick terrain and reading it repetitively. So that's it. I'd ask for questions, but I know you guys are all sitting at your respective computers. Thanks for watching my recording.